scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylasolio. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritia broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future.
Doggerland? No, it's not a country of dogs, as you probably first thought. It's a land the size of Great Britain in the north of Europe. But don't bother trying to find it on the map of the old continent. Your search will come back empty. Doggerland hasn't existed for thousands of years. But where was it exactly? And did humans live here? Scientists are doing their best to answer these questions. Let's start with the name. In the 1990s, a British archaeologist named the area Doggerland after Dogger Bank, a sandbank some 60 miles off the east coast of England. The word probably comes from Dutch. It was used for a fishing boat with 2 masts. Makes sense, since today, the North Sea is a rich fishing area. But thousands of years ago, people living here had a different diet. Some 12,000 years ago, the last major ice age was slowly reaching its end. Doggerland didn't feature seawater, but marshlands, lagoons, forests, and gently sloping hills. At that time, Britain and Ireland weren't islands. They sat deep inland. You could set off in Denmark and walk all the way to the north of Scotland. There was a system of rivers that emptied themselves in the North Sea. Back then, it was more of a channel that separated Doggerland from Norway. The rivers were different too. The Thames flowed into the Rhine. The ancient river they formed flowed into the place of today's English Channel and emptied itself into the Atlantic Ocean. Doggerland even featured a lake. There were some glaciers as well, but the land was still inhabitable. So who lived there? There were communities of hunter-gatherers from the Middle Stone Age. This was the time of human history when our ancestors mastered chipped stone tools. They used these stones with sharp edges for spears and arrowheads. This came in handy at Doggerland, which was the richest hunting area in all of Europe. It could have easily been the most populated region in the northwestern part of the continent. The hunters' prey likely consisted of reindeer, mammoths, oxen, wild pigs, brown bears, wolves, and many other species. In short, nobody went hungry here. Meat wasn't the only thing on the menu. Ancient residents of Doggerland collected hazelnuts and berries. They lived in wooden huts. They built them close to rivers, and they even constructed their settlements on hills. Remember Dogger Bank? It now sits underwater, but it used to be a mountainous region. Doggerland must have been prime real estate in prehistoric times. Its total surface area was over 18,000 miles, but things were about to go under, literally. The last ice age was ending. All the water trapped in glaciers and ice sheets started to melt. You experience this process firsthand every time you order a cold drink. Even if you drink it bottoms up, after a while, the glass is full again. Why? Because the ice cubes have melted. Think of Doggerland as that glass. The sea levels started rising quickly. Every century, the sea flooded from 3 to 6 feet of dry land. Just imagine what this would mean today. Miami's elevation is just over 6 feet. The city would be flooded in less than 100 years. But there was one event that speeded things up. The Storegga Slides were a series of submarine landslides in the Norwegian Sea thousands of years ago. And what happens when huge chunks of Earth shift suddenly underwater? Gigantic waves. You probably know what a tsunami is. Doggerland was likely pounded by several of them. They were so powerful that researchers believe they washed away Great Britain's land bridge to the rest of the continent. All that was left of Doggerland was an island the size of Wales. Scientists estimate that the waves of this ancient tsunami were at least 40 feet high. Some 6,000 years ago, Doggerlanders were on the move. They were migrating to higher grounds, England and the Netherlands in their case. The ironic part is that when we literally translate the name of the country of Netherlands into English, we get lower lands. But thousands of years ago, this was higher ground for hunter-gatherers escaping the flood. Once it was all over, the continent of Europe got the shape we easily recognize today. But Doggerland was nowhere to be seen. It's been sitting under the waves of the North Sea for 8,200 years. Does the idea of Doggerland remind you of a more famous case of a submerged land? The lost city of Atlantis comes straight to mind. But there is an important difference. Atlantis is only a legend. Everything we know about it comes from the writings of the Greek philosopher Plato. Scientists have been searching for Atlantis for a long time. And, up to this day, they can't even agree where exactly it was. Theories range from the Mediterranean to even Antarctica. Doggerland is not a myth. Everything science knows about this lost land comes from hard evidence. In 1931, a fishing boat was doing its thing off the coast of Norfolk in England. At the time, the crew would drag a net along the sea floor, sweeping everything in its path. And they caught something more than fish. It was peat, like the stuff we find in Alaska and in Ireland. But what was it doing at the bottom of the North Sea? It didn't belong there, because seawater destroys peat. There was only one possible explanation. The area must have been dry land at some point in history. The final proof was that the peat contained a harpoon spear point, a sure sign of human activity. The idea wasn't new, though. Since the Middle Ages, there has been talk of submerged land with underwater forests. In 1913, a British geologist came forward with the idea of an undersea world in this part of Europe. Scientific evidence kept piling up. Local fishermen started pulling out human-made tools and animal bones. Researchers dated them to be around 9,000 years old. But the deep, murky waters of the North Sea made it impossible to send down divers. One archaeologist noted that they knew more about the surface of the moon than what lay at the bottom of this relatively shallow sea. The discovery of oil in the area in the 1960s was a real game changer. Companies from the industry provided seismic survey data to scientists. This helped them piece together the full image of what Doggerland used to look like. Computer models soon produced images of river valleys, coastlines, freshwater lakes, and hills. There are even footprints of nomadic tribes preserved on the sea floor. Today, marine biologists are using magnetic fields to map out this lost underwater world. But Doggerland isn't the only place on Earth that went under the waves. Beringia is another lost world of global importance. This used to be a land bridge between Asia and North America. It got its name from the Bering Strait. It is 53 miles wide at its narrowest point. But until the end of the last ice age, this was dry land that our human ancestors called home. Genetic evidence shows that Native Americans lived in Beringia for some 15,000 years. If you want to imagine what this land looked like, think of present-day Arctic Alaska. It was a shrub tundra. There were also small willows and birches. Sorry, no woolly mammoths. Large grazing animals simply wouldn't have had enough food in Beringia, though there were probably elk and bighorn sheep in the area. But the Ice Age wouldn't last forever. Like in Doggerland, sea levels started to rise. This happened some 13,000 years ago. It wasn't all bad news, though. Scientific evidence suggests that around this time, people started moving south. They left the slowly sinking Beringia and crossed over into Alaska. From there, they populated both Americas. These were the ancestors of Native American tribes. Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangaea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangaea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangaea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research, but this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand, and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
So get this, Taylor Swift takes a flight from Los Angeles to Tokyo that leaves at 10 a.m. on February 20th. She's on the plane for 12 hours, but she lands only at 2 p.m. the next day in Tokyo. That's a 28-hour difference. So, how did this time warp happen? Well, it's all because of this wonky line. This is the International Dateline. You know, that imaginary line that slices the globe in half and decides who gets to celebrate the new year first? It's the Line Islands, by the way. But crossing this line doesn't just make you feel like you've stepped into a transporter. It actually changes your day. Cross from east to west and boom, it's 24 hours later. If you travel in the opposite direction, crossing the line from the western side to the eastern side, you go back an entire calendar day. Now, you'd think that the International Dateline would be a nice, neat, straight line in the ocean where the time zones switch. But in reality, it's as if someone took a ruler and said, let's make this complicated. The line zigzags all over the place, wrapping around islands and causing all sorts of head-scratching confusion. For instance, Big Diomede Island and Little Diomede Island are only 2.5 miles apart, but have a 21-hour time difference. And things can get a little more complicated depending on which time zone a country follows. For example, if you travel 659 miles across the dateline from Baker Island to Tokelau, you must add 25 hours. In other words, that's 1 day and 1 hour. And if that doesn't sound weird enough for you, wait, it gets crazier. When it's 6 o'clock in the morning on Thursday in New York, it's still Wednesday night in American Samoa. Meanwhile, over in Kiribati, it's already Friday. Yep, we're talking about 3 different calendar days happening at the same time because of this one imaginary crazy line. This phenomenon occurs every day between 10 o'clock and 10:59 in the morning. So, why does the International Dateline look so ridiculous in the first place? Well, great question. Although these zigzags may seem completely arbitrary, they actually have a logical basis. It's pretty much a made-up concept based on the Earth's rotation. The Earth is always spinning, thank goodness, and it takes about 24 hours, or a day, to complete one full rotation. To keep things in sync, people took the Earth and divided it into 24 time zones, each 15 degrees apart. But what is the starting point for a day on Earth? Well, basically, people needed to figure out which of these 24 zones or lines would be the starting line, or the chronocenter. They needed a reference point, a line where they could begin adding or subtracting time as you move east or west. That line is what we now call the prime meridian. But here's the catch. Deciding where to put this starting line, the prime meridian, is totally arbitrary. The idea of establishing a line where days begin and end goes all the way back to at least the 1300s. Back then, map makers were doing their own thing, picking their own east-west dividing lines called meridians, which, by the way, is just a fancy Latin word for midday. Without a universal standard for when a day officially started or ended, sailors on long voyages just had to wing it, figuring out how to handle the time they were gaining or losing along the way. So, in 1884, people decided to organize this whole mess. 25 nations gathered at the prestigious International Meridian Conference in the United States with one big goal: to decide on a line that would serve as the official prime meridian. Finally, like it or not, they were determined to create the international date line that the whole world would accept and would follow from that point forward. The prime meridian was established in Greenwich, England, and the international date line was placed on the opposite side, running through the 180th meridian. Well, sounds simple, right? But that's when the nightmare really began. The chosen international date line didn't just wander through uninhabited areas. Oh no! It split some countries in half and created all sorts of chaos. I mean, if you divide the world with a completely straight vertical line, you end up with situations where half of a country is one day ahead and the other half is one day behind. Take Kiribati, for example. The country is primarily centered in the Gilbert Islands, which sits just west of the international date line. However, in 1979, their territory got a little bigger with the Phoenix and Line Islands, which are way east of the date line. Suddenly, Kiribati was straddling the international date line. This created a bit of a headache for businesses. Folks on either side could only communicate by radio or phone for 4 weekdays a week. Now, to fix this quirky situation, Kiribati decided to skip Saturday, December 31st, 1994, right off the calendar. So Friday, December 30th, turned into Sunday, January 1st, 1995. And just like that, New Year's Day came a day early. Woohoo! After that, the date line moved eastward to go around the entire country. So the same thing that happened to Kiribati happened to other countries as well. For example, when they got to the Aleutian Islands in Alaska, the line made another detour to include them. And when they got south of the equator, well, guess what? Another eastward bend to cover even more islands. And that's pretty much why the straight line started to get a bit ziggy-zaggy. This wonky line is designed to avoid land as much as possible, so there's less hassle when it comes to changing days. So, no, you can't stand between the international date line, like having one foot in one day and the other in the next. But you can cross it by boat. In fact, some fancy trans-Pacific cruises even offer a time travel package for adventurous travelers who want to cross the line and jump into the future. Now, in the end, the international date line looks this ridiculous because it was constructed based on a series of arbitrary decisions, historical quirks, and a whole lot of confusion. But it's not just because people organized it in the 19th century that there is no confusion regarding time zones today. Another thing that the prime meridian establishes is Coordinated Universal Time, the famous UTC. Now, UTC never changes for daylight savings time or anything else. However, in 1908, Canada decided to spice things up by creating Daylight Saving Time, or DST. Their idea was to set the clocks 1 hour ahead of Standard Time to make better use of sunlight in the spring and summer and fall evenings. The idea was so brilliant that most countries jumped on board, but not everyone. Just look at Nepal. They have never ever used the Daylight Savings Time, which means their clocks do not change throughout the entire year. As you probably know, countries with large territories often have more than one time zone. Just like the United States, which has 11 time zones. Australia has 9, while India Well, India is a special case. Look, India is a big country with an area that stretches around 1,800 miles from west to east. So it should have 3 time zones in total, but they only have one. This means that the sun rises almost 90 minutes earlier in Dong in the far east than in Gujarmoti in the west. And why do they have only one time zone? Well, basically, because they can. Just remember that the international dateline and time zones are invisible, artificial, and now you know, totally arbitrary. So if a country wants to stick with just one time zone to simplify processes and business operations within its border, then hey, why not?
There's a place on Earth so dangerous that even the most fearsome creatures of today wouldn't last a moment there. It used to exist in what we now call southeastern Morocco, the land called the Kem Kem Beds. The story of this place stretches back to the Cretaceous period, about 100 million years ago. It might have looked like a beautiful place at first sight, a lush green forest, rivers glittering in the sun, until you meet some terrifying dinosaur. The lions or sharks of today are nothing compared to what the fossils show us. The Kem Kem Beds were dominated by terrifying predators, and above them all, 3 of the largest predatory dinosaurs ever discovered. For example, Spinosaurus. This dinosaur was unlike anything you can imagine, a half-reptile, half-monster standing over 50 feet tall, bigger than a T-Rex. This hybrid with a crocodile-like snout and a sail on its back hunted the forests. But this dino could dive into the rivers, so not even waters were safe from it. It could catch huge fish, as if plucking them from the shallows. There was also Carcharodontosaurus, a carnivore with the name that literally means shark-toothed lizard. Its razor-sharp teeth could slice through flesh with terrifying ease. This monster stood almost as tall as a house and was faster, stronger, and more aggressive than nearly anything that had ever walked the earth. There was also Deltadromedus, a raptor-like dinosaur built for speed. It was a quick-moving ninja that stalked its prey with horrifying precision. Oh, and the skies were a fun place too, with all these pterosaur creatures flying around. These guys are often mistaken for flying dinosaurs, but they were actually a different kind, more like close cousins of dinosaurs. These majestic reptiles soared above the Kem Kem Beds and had wingspans that could stretch up to 30 feet. The fingers were feathery, with a 4th finger kinda like bats. They could glide through the air so easily thanks to their super light skeleton. But it wasn't just the dinosaurs that made the Kem Kem Beds so horrifying. The waters also hid their own dark secrets. They were home to giant, terrifying fish and crocodile-like creatures. Their jaws were strong enough to crush bone, and they were lurking beneath the surface, waiting for anything unlucky enough to stumble into their path. One of the river creatures was Sarcosuchus, also called the super croc. Being about 40 feet long, it could easily swallow an adult human. Or better yet, it could take on a full-grown dinosaur and win. Its jaws snapped with unimaginable force, and no creature, not even Spinosaurus, was safe from it. Coelacanths could also hang out in the rivers. It was a monstrous predator that could easily swallow a huge fish whole. They had these creepy, icky fins that moved in a way similar to how human arms and legs move. And they could also kind of raise their heads like humans because of a special joint in their skull. Ew. Fun fact, we thought these monsters had gone extinct 60 million years ago, together with dinosaurs. But recently, we rediscovered them living and thriving in the Indian Ocean. Turns out they were just hiding in the deep waters. They probably didn't even notice the dinosaur asteroid or humans at all. Yay? Don't worry, over millions of years, they became basically harmless. They got 4 to 5 times smaller, even though they still weigh about 200 pounds. Just imagine what they were like back in the day. Kem Kem waters were also home to giant lungfish and other creepy aquatic creatures. So you couldn't even drink or take a swim safely without getting bitten by something. Whew, what a place. Even turtles there were the size of cars. Imagine trying to survive in a world where creatures like this are literally everywhere. And I mean everywhere. This place was unique not because huge beasts live there, but because of the sheer number of predators. You might think, it shouldn't be that easy for all these predators to hang out in one place, right? And you're right. Seems like prey was scarce there. That's even more chilling. All the predators just wandered around, hunting whatever meager life remained. And if there's none, then fighting each other. For years, scientists have wondered why it was the case. Maybe that's just how life was back then. And all corners of Earth were crazy like that. Or is there something special about this place? Some even say that maybe it's just because we only found predators' fossils. Well, normal, friendly animals have disappeared, and that the fossil record might be skewed. But who knows? And the environment itself was just as fascinating as the beasts who lived there, just a bit more friendly. It's hard to imagine, but back in the day, this desert was a green paradise, humid and full of rivers. The heat of the sun scorched the land. The climate was hot, so hot that even the poles were warm. The weather there was extreme. Dry seasons followed by intense storms, which shaped the land and life. The giant rivers carved their way through this landscape. They stretched from the Sahara, emptying into the ancient Tethys Ocean to the north. If you were there, you'd see vast, interconnected basins, and beyond them, the central Atlantic Ocean. The floodplain stretched out beneath a sweltering sky. The rivers were just as wild as local animals, flowing lazily one day, but raging like furious beasts the next. At first, these rivers were powerful, carving deep channels through the land and creating wide sandbanks. But over time, they slowed down, and the landscape changed into shallow ponds and salt-covered flats. As water gradually faded away, it left behind a patchwork of wetlands and slow-moving waters. Right now, the Kem Kem Beds is a vast, rugged desert where time has stood still for millions of years. If you visited it, you'd see a giant escarpment, its rocky face winding along the border of Morocco and Algeria, bathed in the sun's harsh light. Beneath your feet would lie layers of fossilized history. That's one of the reasons why scientists were long fascinated with this place. It must be one of the most comprehensive collections of fossils ever discovered in northern Africa. There are fossils from other parts of Africa, of course, like Egypt's Bahariya Formation. But they don't tell us much about life during this time, not like Kem Kem. That's all because those rivers we mentioned in hotter and drier places, they've eroded or still remain buried under the sand. The first discoveries from Kem Kem began in the late 1940s. A scientist named Schubert uncovered bony fish fossils among the escarpment near the Morocco-Algeria border. Just a few years later, a paleontologist, René Lavoca, took things to the next level. Traveling by camelback, he scoured the desert landscape and uncovered a real treasure trove of fossils. He found the partial skeleton of a massive herbivore dinosaur. Finally, at least one peaceful creature in the Kem Kem Beds. This long-necked giant roamed the ancient river valleys and ate leaves like a good boy. For the next several decades, scientists only did small-scale fossil hunting expeditions to this place. There were modest discoveries made here and there. Then, in the 1970s, German paleontologist Helmut Alberti led his team to the Kem Kem Beds, and that's when things took a wild turn. They uncovered fossils of prehistoric fish, crocodiles, dinosaurs, and pieces of the infamous Spinosaurus. Imagine being one of the scientists on that team. They were probably jumping from excitement. By the mid-1990s, the fossil game changed dramatically. Incredible new species were identified from the Kem Kem Beds. Over the years, the discovery pace has only accelerated. Paleontologists, armed with new tools and techniques, have uncovered more fossils than ever before, and there's only more to come.
Wow, this port is so buzzing. Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally, our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, you're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool. Your couch is standing on the floor, your floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere. It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of two plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these two plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruptions slowly push the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the sixth ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that sixth ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid, and before the Red Sea actually starts flowing in there, many thousands, if not millions of years must pass. The continents move as fast as your nails grow. And imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the Afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts, and there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within, and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the Afar Triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to Southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow, just about 1.2 inches a month. Some of them move even 5 times faster though, but even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes, neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangea supercontinent. Even though it formed over 300 million years ago and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangea. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole.
So many asteroids pass through our solar system, and we don't even know about it. Those are rocky pieces of material left over from the time when our solar system was forming, about 4.6 billion years ago. They move around the sun, but not in the way planets do. We're talking about true rebels that prefer to follow some pretty strange paths. Plus, they spin in different ways as they travel between planets and other space objects. And the majority of them come from the main asteroid belt that's located between Jupiter and Mars. Most stay there. But Jupiter has quite a strong gravity, so it can push some of those flying rocks in different directions, and towards us too. They're sometimes round, and sometimes they have odd shapes with pits and holes from all that crashing into other space rocks. As we currently know, there are more than 1 million of them in the main asteroid belt, and that's all good until some of them move in our direction. NASA keeps an eye on them, so we know everything's fine, at least for now. But that wasn't always the case with our beloved home planet. If Earth could talk, it would probably share so many crazy asteroid stories. We're talking about those space rocks that left impact craters we call domes. They have a specific shape with a raised center, similar to when you throw a pebble in a pond and see some water splashing upward. But we'll never be able to learn about many others. I know this raised center sounds like something you're supposed to see right away, especially if an asteroid that once slammed into the surface was big. But we're talking about millions and millions of years of erosion, so wind, water, and even gravity do what they do best and erase traces. They wear down impact domes, and some sites even end up hidden under layers of rock and dirt, or they disappear forever because Earth's tectonic plates keep moving around. Check out the Moon. It's experienced many collisions too, but over there, there's no ocean or tectonic plates moving around, or even wind to slowly, through millions of years, erase craters from its face. Basically, its entire history is written on its surface. But Earth has its own forces that can erase such places as the Vedafort impact structure and the Chicxulub crater. You know, the famous one that wiped out the dinosaurs? Luckily, scientists have new methods to find ancient craters. They often focus on the mess impacts made, which means the materials they threw around. And the Australian continent is especially interesting since we're talking about a playground for asteroid hits. By that, I mean ancient supercontinent Gondwana that dominated the South hundreds of millions of years ago. Experts know about 38 impacts, plus they speculate about 43 more. Some structures are relatively small, while others are big and completely hidden. And recently, a scientist named Tony Yates has discovered strange underground magnetic patterns in New South Wales, Australia. Yay! New clues of a giant asteroid impact! And when I say giant, I really mean it. It's a structure 323 miles in diameter. This might be the largest impact site ever found. This spot is called the Deniliquin structure. Its magnetic patterns show characteristic ripples around the center, like when a rock hits the water. There are also fractures that go outward from the center. And it seems rocks from inside Earth ended up pushed into these fractures. That's a typical story for big asteroid impacts. This structure was probably located in eastern Gondwana hundreds of millions of years ago, way before it split into several continents, including Australia. At the moment, all we know about this crater is what we see on the surface. To find more information about this collision and get some proof, we'll have to drill into the ground. An asteroid this big is definitely not a joke. It could have caused a massive ice age and maybe even wiped out around 85% of species, even more than the asteroid that ended dinosaurs. In 4.5 billion years, which is how long our planet has existed, it's been punched by hundreds of big asteroids. But that doesn't mean every space rock that enters our atmosphere really makes it all the way to the ground. Most of those that manage to pass the atmosphere are relatively small, for instance, 3 feet across. That's good for us because any space rock that's less than 82 feet in diameter most likely won't make it past our planet's atmosphere. Since these space rocks come towards us very fast, they heat up the gases in the atmosphere, which burns them away. By the way, once cosmic intruders enter our atmosphere, they turn into meteors. And in most cases, they don't cause much damage, if any, as they fall down. But we used to have way larger things flying around and crashing into Earth. At least 190 of them have left scars you can still see today. One of the really big ones is in South Africa. It's 99 miles wide. It's actually the largest. At least that's what scientists think at the moment because they still need to check as many details as possible about this new crater in Australia. This one in South Africa formed about 2 billion years ago, and an asteroid that created it was probably larger than the one that had wiped dinosaurs away. And when an asteroid is bigger than 0.6 miles, it can have really big effects across the world. This impact was so strong that it could have caused fires everywhere and thrown lots of dust into the air. And when you have so much dust in the atmosphere, the climate on the planet can change for months or even years. Then we also have the most popular asteroid that made a giant hole we today call the Chicxulub crater. You know the story. It crashed into our planet 66 million years ago when dinosaurs were wandering around, catching food, falling in love. Basically, just doing their thing. The crash itself didn't erase them right away. It threw a lot of debris into space, and when it fell back to Earth, fires and flames were everywhere. The hit also produced a big cloud of dust that covered the planet for years. This cloud blocked the sunlight, which harmed plants and entire food chains. Even those dinosaurs that survived the crash and such difficult conditions had a hard time finding food, so they didn't make it. At least they left us many fossils and turned into the inspiration for movies and stories. A long time ago in Canada, something big crashed into our planet and left a big hole we today know as the Sudbury Basin. People used to think it was an asteroid, but now some experts think it might have been a giant comet made up of a mix of ice and rocks. The hole is almost gone now because of weather conditions though. But people still get to mine iron and nickel there, and at the same time find the leftovers of whatever space object fell there. If you move deep in southern India, you'll find a big hole called Lonar Crater. Locals stumbled upon it 200 years ago and believed it might be from a volcano. But now we know it's a trace from a meteor that crashed into the ground about 35 to 50,000 years ago. What's so special about this crater is that it's the only one known to have formed in a type of rock called basalt. Around the crater, there are hills covered in trees, and animals like peafowls and gazelles live there. Birds also like to visit the lake near the crater during the winter. And the lake itself is quite interesting too. It can turn pink because of all those tiny organisms that live there. But this color change doesn't last long.
Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia. but they behave like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system.
This sleek, state-of-the-art submarine named Ran was sent to explore the depths of Antarctica. But as soon as it discovered something, it mysteriously disappeared. So, what happened? It all started when scientists wanted to explore one of the most remote and mysterious places on Earth, the Dotson Ice Shelf in West Antarctica. This ice shelf, silent giant, stretches 30 miles wide. That's almost the length of New York City. It stands between two icy promontories, the Martin and Bear Peninsulas, and it hides an entire world of geological mysteries. If you think that Antarctica is nothing but a desert of super thick snow and ice, you're wrong. There are entire landscapes hidden deep down there. The underside of the Dotson Ice Shelf is a rugged, dynamic terrain shaped by the slow, relentless forces of nature. There are towering ice formations, deep troughs, and bizarre structures stretching for hundreds of feet. Scientists are super curious about it, but as you can imagine, this landscape isn't easy to explore at all. To find out more, we have to scan the area with satellites or try drilling through the snow, trying to collect the big picture, piece by piece. But these methods only gave us vague hints. The real breakthrough happened when scientists came up with the idea to let the submarines explore it. Autonomous submersibles could swoop deep into the icy waters beneath the Dotson Ice Shelf and tell us what's up down there. These robotic explorers have fantastic advanced sonar systems. It's that thing that bats or dolphins do. They can use sound to see the world. Basically, they send out sound waves underwater, and when those waves hit something like the ice shelf above or the seafloor below, they bounce back to the system. Animals feel how long it took for the sound waves to return and how they changed. And this helped them understand what's located where. For example, clicks that dolphins send out tell them where the fish are. We copied this crazy evolutionary trick and adapted it to our underwater exploration. Only our version is much cooler, with a higher level of precision, so we created detailed maps of the environment. The Rand submarine was one of those robotic explorers. It was named after the Norse deity of the sea. Ran had been meticulously programmed to navigate a treacherous landscape of Antarctica. But even with all this training, its journey led to an unexpected and eerie end. In 2019, Ran was sent to explore the depths beneath the Dotson Ice Shelf. It was a hero, the first one to go on a mission like this. The team said it was like seeing the other side of the moon. For 27 straight days, it worked tirelessly. It traveled over 620 miles beneath the thick ice. That's like a journey from Paris to Berlin. Ran went further and deeper than anyone could have imagined. At one point, it reached over 10 miles into the glacier's belly, and what it discovered down there was astonishing. Scientists thought there would be some smooth, uniform ice surfaces, but Ran revealed an underside marked by huge cracks, ridges. There were formations that looked like sand dunes, frozen in time. And finally, it found some mysterious swirling and teardrop-shaped patterns. They all looked more like art than geology. This actually tells the story of ice shelves and the ocean around it. Warm water sneaks in under the ice and melts it from below. Sometimes it smooths the ice out, but other times it carves out these weird, uneven shapes that look like patterns and drawings. And some of these shapes are huge, over 1,300 feet long. That's about 3.5 football fields. The reason why they look like swirling doodles is because the Earth spins. It makes the water turn in special ways, bending the shapes and drawing these spirals. It's called the Coriolis effect. Imagine you were on a merry-go-round and tried to throw something like a ball. It would go in a curve, not a straight line. Same thing happens with the water on Earth. Later, scientists found similar patterns in other Antarctic ice shelves, though they weren't as epic as the ones under Dodson. But Ran also discovered something horrifying. Turns out that these warm waters, aside from being great artists, are also a huge danger. The Dodson ice shelf isn't just hanging out serenely on the sea. It's part of a very delicate system and acts as a protective barrier that holds back huge glaciers in West Antarctica. The ice shelf is floating on the ocean, but it's still connected to the land. As warm water sneaks underneath it and the ice melts, the Dodson can't hold on to the land as tightly anymore. The protective barrier starts to weaken, and this lets the glaciers behind it move faster into the ocean. When those glaciers flow into the sea, they add more water, which could cause sea levels to rise, eventually changing our coastlines. Rand stumbled upon huge pockets where the ice was melting at alarming rates, all due to powerful underwater currents. It was like seeing a ticking clock on the glacier. The stakes were high, but luckily the submarine was ready. This time, it managed to return. And then, it worked for 5 more years, helping scientists with tons of useful data. The missions were daunting. There could be periods where Rand slipped into the pitch-black cavity beneath the glaciers, spending 24 hours without communication. But it was mapping every peak and every valley. It gained experience from over 40 missions below ice. Then, in early 2024, Rand went on a mission to the Thwaites Glacier. The mission was bold from the start. This place is also ominously referred to as the Doomsday Glacier. It's called that because it's slowly melting and has the potential to raise sea levels worldwide if it collapses, causing catastrophes everywhere. That's why Rand was dispatched to explore its underbelly, a place that had never been mapped so intricately before. The idea was to uncover the glacier's secrets, study how rapidly it was melting, and why. This was Rand's second time exploring Thwaites. During the previous visit, it became the first sub to ever map the glacier's underside. Rand was exploring the depths from 650 feet to 1,650 feet. It sent a lot of data about how the Doomsday Glacier was slowly melting due to warm ocean currents. But while venturing into these icy depths, something went wrong. Out of nowhere, Rand vanished. Without warning, without a trace. One moment it was sending back crucial data, and the next, it had slipped into the abyss. No distress signals, no final transmission, and it didn't return to the point it was supposed to. People sent extensive searches, helicopters soared overhead, drones buzzed through the frozen skies, but no sign of the submersible emerged from the glacier's grasp. After a while, Rand's batteries would certainly run away. So at this point, it had definitely been swallowed by the abyss beneath 1,500 feet of ice. That was a huge and sad loss for the scientific team. The scientists at the University of Gothenburg are now looking to replace Rand and continue their important research under Thwaites. To this day, scientists have no idea what happened to it. Some say it may have been trapped in the ice. Others believe it was pulled away by an unseen current. It also might have collided with something unexpected. Whatever the truth is, its disappearance has left scientists stunned, and it looks like the ice shelf will hold on to its secrets a little longer. At least we gained a treasure trove of knowledge from Rand's journey. Scientists keep exploring Antarctica, looking for history that hides under the snow. For example, they discovered that around 90 million years ago, a lush temperate rainforest thrived near the South Pole. They revealed an ancient world far warmer than they ever imagined. Deep in Antarctica, they unearthed fossilized roots, pollen, and spores preserved in the soil. All this shows that there was a swampy rainforest that flourished despite months of polar darkness. All these discoveries changed our understanding of Earth's climate, both in the past and the future.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing because it sits on the African plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking. And the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a tabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
These days, you're better off boarding a plane if you want to travel from New York to London. But what if I told you there was a time when these two cities were actually on the same continent? Well, the explanation is a bit more complex. For starters, back then, these two cities didn't even exist at all. But the tectonic plates they sit on today were a lot closer. Nearly 200 million years ago, all of the continents on our planet connected, making up one large supercontinent. This enormous piece of land was surrounded by one single ocean. We call this huge continent Pangea these days. Some parts of this continent broke apart and shifted away from each other for our maps to reach their current configuration. There's even a nice experiment you can conduct to test this theory. Find a map online and print it on a piece of paper. After that, simply cut out all of the continents. Once you start playing around with them, you'll soon notice they all seem to fit together, like pieces from a puzzle. Probably the most striking thing you'll see is how South America perfectly fits Africa. What's even more fascinating is that this isn't the first time in our planet's history that supercontinents have been formed and then broken apart. Scientists have figured out that this happened at least 3 times before. And if we consider our planet's age, 4.5 billion years, the last 200 million is closer to the blink of an eye. So how did scientists figure out that continents move? Apart from the aspect of today's continents, they also looked at identical rocks, which have been found on different continents. They looked like they formed from the same minerals and under the same weather conditions. Some other secret helpers? Well, dinosaurs. Fossils from the same species have been stumbled upon in both South America and Africa. This particular dinosaur, named Mesosaurus, is said to have lived on our planet way before the continents drifted apart. It's hard to imagine how life on Earth must have been with one single continent. For starters, the climate must have been very different. That's because the mid-portion of the land would have probably been bone dry, having little to no source of water. More so, it was most likely hidden away behind many mountain chains. These would have acted as a barrier against moisture and rainfall too. However, geologists have also studied coal deposits from the United States and Europe. These seem to show that at least a part of the ancient supercontinent, which was close to the equator, must have been an amazing tropical rainforest, just like those we can find in the Amazonian jungle today. Coal appears when remnants of plants and animals get stuck into swampy water. If enough pressure is applied by the water, the substance is first turned into peat, then into coal. Our planet existed in this continental configuration for over 100 million years, and during this time, there was a lot of life on Earth already thriving. Hey, it was a great time to be an insect. Critters like beetles and dragonflies flourished. During the same time period, the Earth was roamed by the predecessor of all mammals, the synapsid. Life in Pangaea was severely hit during one not-so-great period. It's believed that a comet or asteroid landed on the surface of the Earth about 251 million years ago. The asteroid or comet theory seems to fit pretty well because 90% of all marine animals and 70% of the creatures living on land disappeared all of a sudden. The comet might not have been the only reason for the mass extinction. At the same time, there was also some important volcanic activity happening in northern Asia, which might have disrupted life on Earth. We may not notice it, but continents do continue moving as we speak. This configuration we now see with the help of satellite imagery will surely not be the last. Australia, for example, is slowly moving towards Asia. But the most important proof that our continents are still shifting is the eastern portion of Africa. This area is simply breaking off from the rest of the land. To witness this, you'll have to travel to one of the hottest places on our planet. But if you get to this piece of land on the eastern part of the African continent, you might sit on top of the exact spot that, soon enough, will be split in two by water. Underneath this region, 3 tectonic plates are slowly drifting apart. If the data is correct, in the far future, Africa will be split in 2, and between its 2 regions, a new ocean will arise. To support this theory, scientists have been closely studying a 35-mile-long crack in the Ethiopian desert for years. For this new ocean to form, it's estimated that 5 to 10 million years need to pass. Since our planet's crust is made out of multiple tectonic plates that are constantly moving, it's the perfect place to study this process. These plates are all irregularly shaped, and they are always mashing against, sliding under, or over each other. Those 3 tectonic plates found under the desert are also moving at different speeds. One of them, called the Arabian Plate, is sliding away from Africa at a speed of about 1 inch per year. The other two plates are moving a bit slower, somewhere between ½ an inch to 0.2 inches each year. More so, as these movements happen, material from deep inside Earth climbs to the surface and forms an oceanic crust at the edges. All this movement does make you wonder, how will the next supercontinent form, and when? So far, scientists came up with some possible configurations, each with its own name: Novo Pangea, Pangea Ultima, or Amasia. All these predictions still vary, as we're not sure how and why continents really move over time. One clue may be actually looking at how Pangea separated in the first place. Regardless, it will take anywhere from 15 to 100 million years to see the next future continent, depending on each scenario. Novo Pangea looks at the possibility in which present-day movements continue. In this scenario, the Atlantic Ocean will continue to expand, all the while making the Pacific smaller. The two American continents would first combine northward. Africa, Europe, and Asia will have already combined too, by the time they all meet together in one single huge piece of land. Another possible scenario is called Pangea Ultima. In this case, the Atlantic will slow down in its expansion and actually become a landlocked body of water. North America, Africa, Asia, and Europe would become somewhat parallel pieces of land, completely sewn together. Underneath them, South America, Antarctica, and Australia would complete the circle surrounding the North Atlantic. All the while, this piece of land would be surrounded by a large Pacific Ocean. Amasia looks at a scenario that's a bit difficult to understand and study at this point. Since several tectonic plates look like they are moving north, it might be possible that all continents, apart from Antarctica, will slide completely toward the North Pole. The climate would be a lot different and way colder. Both the Pacific and the Atlantic, in this scenario, would remain open bodies of water. Scientists believe this to be a real possibility because of some anomalies left by Pangea deep in the Earth's interior in the part called the mantle. Looking even further into our planet's future, it's estimated that in about 1 billion years, the luminosity of the sun will be somewhere around 10% higher. As such, the atmosphere on Earth will closely resemble that of a moist greenhouse. Because of the added heat, all the bodies of water on our planet will start to rapidly evaporate. Moving further to 4 billion years from now, the temperature on our planet will soon transform it into a Venus look-alike. It might get so hot that the Earth's surface will begin to melt away.
So it turns out that you can't drive between South America and North America. And there's a simple reason for that. There are no roads connecting the two continents, not even a rudimentary one. Technically, you could try your luck crossing on foot, but let me tell you, that would be a huge mistake. The region that connects the two continents is called the Darian Gap. It stretches across southern Panama's Darian province and the northern part of Colombia. The only land route there is a 60-mile jungle trek. Crossing it can take anywhere from 3 to 10 days. It depends on weather conditions, how much you're carrying, and honestly, just pure luck. Chance plays a big role here, because this isn't some chill, relaxing nature walk. It's a harsh, extreme environment, known for being completely isolated and one of the most dangerous places on Earth. Still, people seem to forget that and go there anyway. Every year, the number of people crossing just keeps growing. In 2014, fewer than 10,000 people crossed the gap. In 2023, that number increased to 520,000. Now, you might be wondering, what are so many people doing in the middle of the two American continents, risking all that danger? Well, that's because the Darian Gap has become a route for refugees migrating to North America. But to get there, they face all kinds of dangers, from insect bites and infections to serious fractures. We're talking about a no man's land. Since there are no police stations, Immigrants must also watch out for thieves. Along the way, they have no choice but to rely on and support each other. Most people start the crossing with at least a tent or tarp, rain boots, water, and some food. But these things get heavy fast, and people normally can't carry enough supplies for the entire journey. At some point, people start drinking river water to avoid dehydration. But the water's full of bacteria and dirt, so it causes intestinal issues. And if things get serious, there's no medical help there. To make this whole scenario even worse, the temperatures are brutal, often hitting over 95 degrees Fahrenheit. Now, a small subset of people who venture through the Darian Gap are hardcore adventurers and travelers looking for a survival experience in the jungle. But this region is no place for a relaxing vacation. A group of tourists who went there in 2023 ended up getting jungle rot, a fungus that affects the feet. The situation got so bad that a woman had to be carried out by the group on the last day because she couldn't walk. No matter how prepared people are for the Darian Gap, in the end, survival mostly comes down to luck. Out there, travelers won't find cities with solid infrastructure where they can crash at a hotel and gear up for the next day. In some spots, they might stumble across basic camps right in the jungle. These camps might offer wooden platforms for tents, bucket showers, toilets, and even plates of chicken and rice. But it all comes at a price. Wi-Fi, for example, might cost $2 an hour, and that seems like a pretty good deal, considering there's no cell phone service on the trail. They pretty much lose all contact with the outside world. Now picture a dense rainforest with steep, muddy terrain. The hiking trail is littered with boulders and tangled with vines, like nature's own tripwires. It climbs sharply over a mountain, becoming a serious challenge even for someone in good physical shape. The area also gets constant heavy rainfall, which can lead to landslides, flash flooding, and extremely muddy conditions. The situation gets so intense that even the t-shirts and faces of those who make the crossing end up covered in mud. They'll also have to cross a lot of fast-moving rivers. A Venezuelan dad who recently went through the area with his 2 kids said their sneakers ripped apart on the very first day. That's how powerful the rivers can be. And they're deep, too. Sometimes the water reaches all the way up to their shoulders. But the dangers in that area aren't recent. For centuries, the Darian Gap was thought to be impossible to cross. The first Europeans who ventured into Latin America saw it as kind of a jungle training school. They totally knew about its dangers, but still, many adventurers tried to make the crossing in the years that followed. In 1854, for example, an expedition disappeared for 49 days in the jungle, battling starvation and exhaustion. Then again, in 1870, a group of 100 men set out to cross it. Even though they were well prepared and carried cutting-edge equipment for the time, they still suffered tremendously during the journey. They had to rely on incredible resilience to survive the challenge. Over the years, people who ventured in often ended up passing away from hunger, thirst, and even drowning in rivers. They also faced the risk of being attacked by dangerous animals like jaguars, white-lipped pecaries, and the fer de lance, a fast, irritable snake that is one of the most venomous out there. The area is also swarming with mosquitoes, which can spread serious health problems. Leaning against trees to rest can also be risky. This jungle is full of spiked chunga palm trees, which are covered in long black spines up to 8 inches long. Unfortunately for us, these spines are covered in all sorts of bacteria. Just brush against a chunga, and you could end up with infected wounds. And yet another danger is getting lost in the dense forest and never finding your way back to safety. These days, though, this risk is a lot lower. Some people have mentioned color-coded markers that help guide travelers and keep them from going the wrong way. If they see blue or green fabric tied to trees, it means keep walking. But if they spot red fabric, that's a sign they're going the wrong way and need to turn around quickly. Since there are so many dangers, why not just build a road through the Darian Gap? While it might seem like a good idea, building a road connecting Panama and Colombia isn't really that simple. The Darian Gap has a humid climate, tough terrain, and constant rainfall, which means any attempt to build a functional road would be highly challenging and super expensive. Even though there have been previous attempts to fill in the gap. See, there's a huge road system called the Pan-American Highway, which stretches all the way from Alaska to the southern tip of Argentina. Nowadays, this highway hits a roadblock right at the Darian Gap. But it wasn't supposed to be like this, as the original idea was for the road to go through there. Leaders from Latin American countries tried to make this plan happen in the 70s, and then again in the 90s. But a lot of people were against it, mainly because they wanted to protect the local communities and the rainforest. Since the Darian Gap is mostly untouched by humans, it's one of the most biodiverse places on the planet. It's believed that 1 in 5 species are endemic to the region, meaning they only exist in that specific area, like the Darian pocket gopher and the slatty slender mouse opossum. A road would have really damaged the ecosystem in the area, so the plans were scrapped. Eventually, an alternative was created to travel by sea. At least 2 companies started a ferry service connecting the 2 countries. However, the business wasn't profitable, and they ended up shutting down. Not long ago, Panama decided to close the Darian Gap route. Now they're sealed off with barbed wire fencing. It might just be a matter of time before other routes are created. But if you are an adventurer looking to visit South America, it's probably not best to wait for that. Traveling by plane to Colombia will always be a much safer option.
This invisible line divides the world into 2 parts. And most animals, fish, and birds, for some reason, can't cross it. The line is called the Wallace Line, and it runs between Australia and Asia. It has its name after Alfred Russel Wallace, a British scientist and explorer who discovered it in 1859. He traveled to Asia to explore a group of islands called the Malay Archipelago. As Wallace walked through the jungles, climbed hills, and sailed on boats, he noticed something like an invisible wall. On its west side, in places like Borneo and Sumatra, he saw animals you might find in Asia. There were big rhinos munching on leaves and monkeys swinging from tree to tree. The forests were full of life, with all kinds of animals you'd expect to see in a jungle. But in places like Sulawesi and Lombok, just across the imaginary line he came up with, Wallace found animals more like the ones in Australia and colorful birds like cockatoos. The behaviors of animals differ on different sides of the Wallace Line. Some creatures are great at traveling across tough barriers like water, but others are not. For example, bats can fly across open water, but they sometimes cross the Wallace Line. On the other hand, big animals that live on land like elephants usually stay on just one side of the line. Some birds are shy and like to stay hidden in thick bushes and trees to avoid predators. They wouldn't feel safe flying over wide stretches of water with no place to hide. Plants don't stick to the Wallace Line as strictly as animals do, because they spread in their own unique ways, like with seeds carried by the wind, water, or animals. One plant genus, the eucalyptus, mostly stays on the Australian side. But one eucalyptus tree has made its way to the Philippines on the Asian side. Underwater, the Wallace Line doesn't matter as much. The area between the Wallace Line and Australia is called the Coral Triangle, and it's bursting with life. Now, after more than 150 years, scientists think they finally have an explanation of the Wallace Line mystery. They believe it all started about 35 million years ago, when Australia broke away from Antarctica and slowly moved up to crash into Asia. When this happened, the crash created a chain of islands called the Malay Archipelago between Asia and Australia. This caused extreme changes in the weather, which made the area very different and affected which animals could live there. Researchers used a computer model that looked at how more than 20,000 species of animals from both sides of the Wallace Line would have behaved millions of years ago. When Australia started to drift away from Antarctica, it opened up a huge new era of deep ocean around Antarctica. This is where the biggest ocean current on Earth, called the Antarctic Circumpolar Current, began to flow. This swirling current made the planet's climate much cooler and completely changed how animals could live in different places. But not all animals were affected in the same way. Indonesia stayed warm and rainy, which was perfect for animals from Asia. These creatures could hop from island to island like stepping stones and make their way toward Australia. But animals from Australia had a harder time. Over millions of years, they had gotten used to living in cooler, drier places, so the tropical islands didn't suit them as well. Scientists believe if we can see how animals adapted to big changes in weather patterns millions of years ago, we might be able to predict how today's animals will cope with a similar situation. Other scientists after Wallace also tried to describe and explain the invisible natural border between Asia and Australia, and came up with their lines. The Weber Line, for example, is in a slightly different location than the Wallace Line, between the Oriental and the Australasian faunal regions within Wallacea. It's a group of mainly Indonesian islands that are separated by deep water straits from the Asian and Australian continental shelves. They were never connected to the big continents by land, so animals that could swim, fly, or float across the water made it to these islands. That's why the creatures living there are so unique and come from both Asia and Australia. Weber's line is where the balance tips. If you go one way, most of the animals are from Asia. If you go the other way, most of the animals are from Australia. Another important migration event in the history of our planet happened in the Americas. Around 30 million years ago, South America became a separate landmass as tectonic plates moved and pulled it away from Antarctica and Africa. Once it was on its own, the animals living there started to evolve in unique ways and turned into creatures you couldn't find anywhere else in the world. There were animals we still see today, like opossums, giant rodents like capybaras and chinchillas, armadillos, anteaters, and sloths. Some of the animals from those times are now extinct. There were giant ground sloths, bigger than cars, roaming around. There were glyptodonts, which were like giant armadillos with super tough, bony shells. There were also huge, scary birds that couldn't fly, but could chase down their prey. Up in North America, animals could still travel to other parts of the world through the Bering Strait. So North America was full of different animals like deer, bison, horses, camels, and even mammoths and mastodons. They all lived alongside predators like big cats, wolves, and bears. About 3 million years ago, the continents of North and South America got connected by a strip of land called the Isthmus of Panama. It formed because the tectonic plates shifted again. Some major volcanic activity between 25 million years ago also contributed to the process. Animals started to move between North and South America, and this long process went down in history as the Great American Interchange. During the Ice Age, huge glaciers in the north grew and shrank over tens of thousands of years. When the glaciers were at their biggest, they held so much water that the sea levels dropped, and forests probably turned into wide grassy plains. So animals had the perfect conditions to cross over. Giant ground sloths were among the animals that went up north from South America, all the way to Alaska. One special kind even roamed the chilly tundras alongside woolly mammoths and caribou. Lots of North American predators decided to explore the South. There were cats like cougars, jaguars, and saber-toothed tigers with their giant teeth. Wolves, foxes, otters, raccoons, and bears also joined the migration. The short-faced bear could stand up to 13 feet tall and weigh as much as a small car. South America also had some funny-looking animals called sanus, or South American native ungulates. These were hoofed mammals that evolved into all kinds of weird shapes, while South America was isolated. Big animals from North America, for example, relatives of elephants with strange tusks, came to the south and became some of the largest creatures around. The ancestors of today's llamas settled in the Andes Mountains, and deer, tapirs, and peccaries thrived in the forests. Animals kept moving back and forth between the continents for thousands of years. But as the Ice Age ended, many of the bigger animals, like the giant ground sloths, couldn't adapt and disappeared. It seems North American animals were better at adapting to their new homes. You can find armadillos, porcupines, and opossums from South America in North America. But many of South America's most famous animals like jaguars, llamas, and spectacled bears left North America long ago. Scientists think South America's animals, after being isolated for millions of years, had a harder time dealing with new challenges when their ecosystems changed. I guess it's no surprise that it's not that easy to just hop on a plane and literally fly to the South Pole, aka Antarctica. Sure, there are airports down there, but they're not really set up for commercial flights. So most people go to Punta Arenas International Airport in southern Patagonia, Chile, and then take a boat if they want to see some penguins. But not only is it hard to fly there, it's even harder to fly over there. When you're cruising at 30,000 feet, you probably don't think much about what's happening below. But it's pretty unusual for flights to go directly over the South Pole, and planes flying across Antarctica are quite rare too. Technically, it is possible. I've already mentioned that there are airports there. But even so, the infrastructure down there is still super limited. There simply aren't enough airports or refueling stations to support regular commercial flights, making it tricky to operate in such a remote area. Plus, there are only a handful of specialized cargo and transport flights that go in and out, and they exist to cater to those few folks who actually live in Antarctica. Then there's the weather that drives up the costs. The simplest example is that the pilots there need special training, which costs money, which is all because of the weather. Another hurdle is something called ETOPS. These rules dictate how far twin-engine planes can fly from an airport. Since there are so few airports in Antarctica, it's tough for pilots to stick to these regulations. Historically, ETOPS made it next to impossible to fly close to or over the South Pole, while flights over land have plenty of airports to choose from. Antarctica is a whole different ballgame. These days, some aircraft can fly up to 330 minutes, or, in rare cases, even 370 minutes from an airport. But even with those extended limits, certain parts of the airspace above Antarctica are still off-limits. Still, in the grand scheme of things, that might not be a huge deal. The most curious of you must have Googled that already and found out that there really are Antarctic airways. Please do not judge fast, and don't say I wasn't right saying how hard it was to fly to the South Pole. Let me break it down for you. Antarctic Airways advertise as the world's most exclusive transcontinental flight, but don't think you can just waltz in and book a ticket anytime. For starters, Antarctic Airways mostly operates flights to King George Island from December to March, so it's not all year round. But there are many more reasons why these flights are unique. If you dig into their website, you'll find you've got two choices: a full day in Antarctica or an overnight adventure. Prices kick off at $5,500 for a day trip and go up to $6,500 for an overnight stay. And if you're considering a private charter, get ready to shell out a pretty penny. It's rumored to start at around $125,000. Sure, that's a steep price compared to your average cruise ship crossing the Drake Passage, but here's the thing. It's about 20 times faster. A cruise ship takes 2 days from Chile, while Antarctic Airways gets you there in just 2 hours. Air travel to Antarctica is pretty limited, likely due to the high costs, limited seating, and the logistical challenges that come with flying to such a remote location. Plus, flights can often be delayed because of bad weather. Most travelers opt for a quick day trip or an overnight stay on King George Island, usually aboard smaller Beechcraft King Air 300 aircraft. The experience typically includes a stroll to a research station and a boat ride to see nearby penguin colonies. But that's just scratching the surface of what Antarctica has to offer. But once you're aboard Antarctic Airways, you'll see it's just like a regular flight on a smaller plane. You'll be served meals that have received some pretty good reviews. There are even photos floating around online showcasing the food, and honestly, it looks awesome. Those who've experienced it say it's luxurious yet unpretentious. You'll get a mix of meats and cheeses, plus treats like tiramisu, salmon salad, a single after-eight chocolate, and a selection of quality street candies. Today, everything may seem cool and safe, but back in the day, there were some pretty tragic events. On November 28, 1979, Air New Zealand Flight 901 tragically collided with Mount Erebus on Ross Island, Antarctica. Unfortunately, all 237 passengers and 20 crew members aboard lost their lives that day. Since 1977, Air New Zealand had been running regular sightseeing flights over Antarctica. This particular flight took off from Auckland Airport in the morning, with plans to spend several hours exploring the stunning Antarctic landscape before heading back to Auckland via Christchurch that evening. Initially, the inquiry into the incident pointed the finger at pilot error. However, growing public concern led to the establishment of a Royal Commission of Inquiry for a deeper investigation. The commission found that the crash had been primarily due to a change in the flight path coordinates made the night before, which the flight crew hadn't been informed about. As a result, instead of being guided by the computer down McMurdo Sound, as they were led to believe, the aircraft was mistakenly redirected toward Mount Erebus. In a way, this flight looks like modern one-day Antarctic tours. Flight 901 was marketed as a unique sightseeing adventure, complete with a knowledgeable Antarctic guide who highlighted various scenic spots and landmarks through the plane's public address system, while passengers enjoyed a low-altitude tour of McMurdo Sound. These flights operated as day trips, taking off from New Zealand and returning on the same day. The plane departed from Auckland International Airport at 8 a.m., aiming to land in Antarctica, with a scheduled return to Christchurch International Airport by 7 p.m. The total journey covered about 5,360 miles, including a 45-minute stop in Christchurch for refueling and crew changes before completing the final 464 miles back to Auckland, arriving at 9 p.m. Back in November 1979, tickets for these flights were priced at $359 per person, which is over $2,150 in today's money. Anyway, this tragedy isn't the reason why planes don't fly over the South Pole. The real culprits are weather, ETOPS regulations, and of course, penguins. Yep, those cool, friendly little creatures. Friendly, at least according to researchers. With no natural predators on land, all of them are in the water. They're not really afraid of people and actually seem to enjoy our company. The South Pole is completely uninhabited and packed with penguins, making it pretty tricky to build anything down there. By the way, the North Pole actually allows planes to fly over it. Not too long ago, there were direct flights from Copenhagen to both LA and Tokyo, operated by SAS, and they cruised right over the North Pole. Other airlines joined in too. For example, Emirates ran a flight from Dubai to LA that took the same route. The difference in air traffic between the two poles mainly comes down to where people live and how much land there is. Roughly 88 to 90% of the world's population hangs out in the Northern Hemisphere, while only about 10 to 12% call the Southern Hemisphere home. Most folks in the South are clustered around the equator in places like Indonesia, Central Africa, and Brazil. When it comes to flights heading to the South Pole, options are pretty limited. You mainly have routes connecting New Zealand and Australia, parts of southern South America, and a few spots in southern Africa, especially South Africa. There aren't really any direct flights over the South Pole, though some flights can get close to Antarctica. One possible route could connect Auckland, New Zealand to Cape Town, South Africa, but there aren't any scheduled flights for that right now. The few flights that came close to Antarctica are operated by Qantas and LATAM Airlines, linking Australia with Buenos Aires and Santiago de Chile. In 2021, Qantas took a long detour over parts of Antarctica on a flight from Buenos Aires to Darwin, and in July 2023, they adjusted a route closer to the continent to dodge some fierce headwinds on a trip from Santiago to Sydney.
Picture this. You're floating about in the depths of space, gazing down on our blue marble of a planet. What's on top? You might think it's the North Pole, but that isn't necessarily so. The truth is, our collective belief that the North is at the top of the world doesn't have any solid scientific backing. It's just one of those things we've accepted over time. And this acceptance has a compelling history, with a dash of astrophysics, a bit of psychology, and a surprising twist. It influences how we feel about our world more than we might think. Figuring out where you are is crucial for survival, and that's true for most species, not just us humans. Similar to honeybees, for example, humans have a knack for creating mental maps of our surroundings. But where we really stand out is in our efforts to share these maps with others. We've been at it for a while now, drawing maps on anything from cave walls to computer screens. The earliest ones we've found date back to 14,000 years ago. Despite this long history, it's only in the last few centuries that we've decided that the North should consistently be at the top of the map. History buffs tell us that for a long time, the North was hardly ever at the top because it symbolized darkness. The West didn't make the cut either, given that's where the sun bows out each evening. However, early Asian maps seem to defy this trend. Now, before you say it, their compasses weren't the reason they put North at the top. Early Asian compasses were actually aligned to point south, seen as a more favorable direction than the cold, dark north. But in these maps, the emperor, who resided up north, was always placed at the top, with his loyal subjects gazing upwards towards him. Looking back, every culture had its own idea of what was worth looking up to, leading to varied orientations of early maps. The Egyptians preferred the east, where the sun graces us each morning. Early Arabic maps favored the south. European maps from the same era put the east at the top. So, when did everyone decide that north was the new top? You might be tempted to credit it to explorers like Columbus and Magellan who navigated by the North Star, but they didn't really see the world in that light. Columbus, for instance, saw the world with the east at the top, believing he was headed toward paradise. Mercator's 1569 world map was a game changer, considering it was the first to factor in the Earth's switch to more accurate navigation. But even then, the emphasis wasn't on the north. Mercator projected the poles to infinity, considering them relatively unimportant as sailors didn't venture there often. It's possible that the choice to place north on top was simply because the Europeans, who were doing their fair share of exploring, were located in the northern hemisphere with a whole lot more land to cover and people to meet. For whatever reason, this north-up idea has stuck. Even when a NASA astronaut in 1972 snapped a photo of the Earth with the south at the top, it was flipped over to avoid confusion. Here's where it gets interesting. When you gaze at Earth from space, the concept of up and down loses all sense. Sure, Earth aligns with the plane of other planets in our solar system because we all share a cosmic birth story, but we could just as well flip the image or put the sun on top or bottom depending on your cosmic viewpoint. Even within the Milky Way, our solar system is tilted by about 63 degrees. If you think about it, the concepts of up, down, left, or right don't really apply in space. But how about a change of pace? Should we be open to viewing our world from a different perspective? There's some psychological evidence that our north-up mentality might be skewing our perceptions of value. Most folks consider the north to be up and the south down. It even made psychologists wonder if these associations might influence how people value different places on a map. When shown a map of a made-up city, people were more likely to choose a residence in the northern part. And when asked where hypothetical people of different social status would live, they allocated the rich to the north and the less fortunate to the south. It's not too big of a leap to speculate that humans might be less bothered about what happens to regions lower than where they are on the map. But there's a simple solution: flip the map upside down. These experiments showed that this simple action wiped out the north equals good bias. On that note, south-up maps are already available online. Australians would enjoy this change, that's for sure. Whatever it is that you'd prefer at the top of your map, you would need a compass to guide you. Have you ever paused to think of its system? It is one of the oldest gadgets we've got in our survival toolkit. It's been around for centuries, serving as a beacon for adventurers, travelers, and explorers, guiding them through uncharted oceans and helping them discover new continents. Basically, compasses turned humans from stay-at-home types into globe-trotting nomads. Our beautiful blue planet isn't just a spinning ball in the cosmos. It also has its own magnetic field. Imagine it as a colossal magnet, humming with invisible energy. This is all thanks to Earth's core, a ball of molten iron under terrific pressure right at the center of our planet. This core, part liquid, part solid crystal, churns and swirls due to Earth's spin, creating the magnetic field that gives us our north and south poles. But here's where it gets a bit complicated. These magnetic poles don't perfectly line up with the Earth's geographic poles, the ones that the Earth spins around. They're close, sure, but not exactly in the same place. This is why the compass, which reacts to magnetic fields, doesn't point directly to what we call true north, which is the geographic North Pole. Instead, it points to the magnetic north, located a bit off from the true one. But don't worry, it's close enough to get us where we need to go. Let's talk more about this true north versus magnetic north business. Remember the piece of news from September 2019, when for the first time in over 360 years, compasses at Greenwich pointed to the true north? Well, that's quite a rare occurrence. Usually compasses point towards magnetic north, which isn't a constant spot on the map. It changes and drifts over time, following shifts in the Earth's core. On the other hand, true north refers to the geographic North Pole, a specific unchanging point on Earth's surface. So when you're holding a compass, it's really the magnetic north it's directing you toward, not the true north. Here's where things get even more fun. The angle between the direction of the true north and the magnetic north, as shown by the compass, is called declination. It's a fancy word for a simple concept. Now, because Earth's magnetic field isn't a simple, straightforward thing, it has its wobbles and dips. The declination isn't the same everywhere. It varies from place to place. Also, here's what it's made of. It has this tiny needle that's made from a metal that's been magnetized. Iron's a common one. They set this needle on a little pointy thing, or pivot, and let it float in some kind of liquid. Often, it's mineral oil, or something similar. This lets the needle spin around and dance with the Earth's magnetic field. When you hold your compass flat in your hand, the needle settles down and points to magnetic north. Now, look at your compass and you'll notice these small markings. They're known as degrees, and here's the fun bit. The needle's red end always points north, and the white or black end always points south. That's your compass's north-south dance. Plus, there's often an arrow on the compass case, right at the top. That's your orientation arrow.
In Asia, there's a bridge that is way longer than you'd think should even be possible. The HZMB stretches 34 miles over open water, which makes it the longest sea bridge in the world. So if something this massive can make it across rough waters, why can't New Zealand just build a bridge between its two main islands? After all, we're talking about a distance of just 14 miles. And a bridge like that could seriously change life for both locals and tourists. People could just hop in a car and drive from Wellington to Picton. No more ferry hassles, no more drawn-out trips. Just one epic road journey with ocean views on both sides. So what's stopping them? Well, turns out, everything. I mean, building a bridge there is technically possible, but there are a couple reasons why experts are like, maybe not. Let's start with the obvious, the distance. The North Island and the South Island are separated by Cook Strait. Like I said, it's 14 miles wide at its narrowest point. That's not much, true. Plus, we've got the HZMB bridge, proving that, yep, it is technically possible to build a bridge over the sea to cover that distance. But we can't ignore the fact that New Zealand's geography is, well, a whole different ballgame. Cook Strait isn't exactly a calm, friendly stretch of water. It's deep, really deep. Parts of it drop to about 10,000 feet. That's like stacking 7 Empire State Buildings on top of each other. It's also a rough, moody stretch of ocean that loves tossing around ships like rubber ducks. In fact, quite a few have been wrecked in Cook Strait. And sadly, many lives were lost. You don't have to worry about it so much though, as the worst accidents happened a long time ago. The ships and ferries that cross it today are much safer. Even so, it'd be pretty hard to avoid getting seasick while crossing it. Things get even messier below the surface. The seafloor over there is uneven and unpredictable. What happens is that Cook Strait has opposing tides at each end, one where it meets the Tasman Sea and the other where it joins the Pacific Ocean. And they simply don't move together like you might expect. When the tide is high on one side, it's low on the other, and they're totally out of sync. So all that water rushes back and forth through the strait to balance things out, creating some really strong and messy currents in the middle. Then there's the weather. Cook Strait isn't just windy, it's probably one of the windiest places in the southern hemisphere. That's because it's located right in the middle of one of New Zealand's 3 big wind tunnels. Basically, there are places where the wind doesn't just come and go quickly. It sticks around, blowing hard for most of the year. And all of this happens because of something called the Roaring Forties. That's the name for the latitude band between 40 and 50 degrees south of the equator, where strong, persistent westerly winds are pretty common. Unlike the northern hemisphere, which has a lot of land at this latitude, the southern hemisphere is mostly ocean with just a few land masses, like New Zealand's South Island, Tasmania, and the southern tip of South America. So, these winds go wild because there's nothing to slow them down, and they just keep picking up speed. The gusts there can reach up to 150 miles per hour. So, imagine trying to cross a bridge in a car when the wind is actively pushing against you. That's not just unpleasant, it's super dangerous. Drivers can easily lose control of their cars with the wind pushing them sideways. And of course, that can lead to countless serious accidents. Now, let's talk about earthquakes. New Zealand sits right on the boundary of 2 massive tectonic plates, the Indo-Australian and Pacific plates. It's basically in the middle of a collision zone. And about 14,000 earthquakes happen in and around the country every year. Of those, only about 200 are big enough to be felt. Still, building a massive bridge under these conditions would require some serious genius-level engineering. With all that in mind, we can safely say that the whole bridge idea is off the table. But how about an underwater tunnel? Yep, that could work. It could be a great solution actually. No wind, no bad weather, and no earthquakes to deal with. There are a bunch of other advantages too. First, it would dramatically reduce travel time, cutting down the 3 to 4 hour sailing trip between the North and South Islands. That same journey would probably only take about 40 minutes. Then people wouldn't have to stress about all the ferry cancellations and delays because of bad weather. And most importantly, it's doable. I mean, look at the Channel Tunnel. It's an undersea tunnel connecting southern England and northern France. Japan did something similar with the Seikan Tunnel, which connects the islands of Honshu and Hokkaido. They are both huge projects, serving pretty much the same purpose. So why on earth isn't New Zealand already building this tunnel? Well, for the same reason we don't all live in luxury treehouses with personal robots: money. Estimates vary, but some experts think a project like this could cost anywhere from $10 to $20 billion. To cover that kind of cost, they'd probably need to charge tolls for the next 100 years. And trust me, those tolls wouldn't be cheap. Other experts think it could actually cost more than that. Because you see, we have to consider all the extra infrastructure. The narrowest point of Cook Strait is between the North Island and Arapawa Island. That's one of the long, mountainous regions in the Marlborough Sounds, which is pretty remote. So it's not just about the cost of the bridge or tunnel itself, it's also the access roads, safety systems, maintenance, and evacuation plans. You can't just build a huge underwater tunnel and not plan for the occasional emergencies. And what would it actually be used for? Sure, there are people who travel between the islands. About 1 million passengers take the ferry every year. But that's not exactly the kind of traffic that justifies the most expensive infrastructure project in the country's history. Earlier, we talked about how England and Japan have similar underwater tunnels. But there's something to consider. The United Kingdom has a population of 69 million. Japan has even more, with around 123 million people. And in New Zealand, they've only got 5 million residents to pay for this project. So could they have a tunnel under Cook Strait? Sure they could. Should they? Probably not. If you don't want to fly, the only other way to travel between the islands is by ferry. It's not ideal, but hey, it works. New Zealand has a total of 5 ships that transport people and vehicles across the islands. For tourists who aren't in a rush, it's perfect. You can cross the islands while taking in some of the most stunning views and spotting amazing wildlife. You'll start your trip in Wellington, and right from there, you'll see the rugged North Island coastline as you head out into open water. You might see different seabirds like gulls and terns, and as you get closer to the South Island, you might spot some gannets. If you're lucky, you could also catch a glimpse of the seal colonies off the coast. During the last hour of the trip, the ferry will slow down, giving you plenty of time to enjoy the green hills and calm waters. You will also approach Queen Charlotte Sound, a spot known for its wildlife. So keep an eye out for orcas, playful dolphins, and even penguins. Honestly, having a ferry instead of a tunnel might not be so bad after all.
Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other land masses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's 8th continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The Lost Continents landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritia. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritia. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Sahul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species develop differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Sahul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. I'll bet you've heard of the lost civilization of Atlantis sinking into the waters off the coast of ancient Greece. The story is supposed to be a myth, but have scientists finally found the lost city? Not sure about that, but they did find a lost continent. Wait just 1 minute, I've lost socks, keys, and even a few marbles. But how careless do you have to be to misplace an entire continent? We'll have to ask our planet about that one. Earth lost what was called Greater Adria between 100 and 120 million years ago. So, how did that happen, and where did it go? The only way to describe the process would be kind of like a snake slipping through rocks or going down into a hole. It's easier to imagine losing a continent when you think about how hard it is to find a snake that's escaped your curious stares. Most snakes don't leave trails. In fact, if you weren't around 100 million years ago to watch that snake slide beneath a boulder, and I wasn't, you'd never know it happened. Just like scientists might never have found Adria if it weren't for the snakeskin, the mountains. Let's say your fleeing snake slithers under a rock. It's long past due for a shedding, so its old skin scrapes off and bunches up right there in that tiny space between the boulder and the ground. That's what Greater Adria did. When it broke off from a humongous landmass known as Gondwana, stick around for more on that here in a few, the Greenland-sized chunk headed north. When it eventually crashed into Europe, it slipped under and caused the meeting place of the two continents to fold and scrunch up. For years and years, it just kept going, and those folds kept growing. In the end, it left behind very obvious and famous traces. You might even have gone skiing on them during a winter vacation. I'm talking about the Apennines and the Swiss Alps. Professor Douwe van Hinsbergen, the geologist who led the research team responsible for this colossal discovery in September 2019, has his own analogy. He compares this folding action to what happens when you stick your arm into a small space and your shirt sleeve can't fit through. It bunches up, and those bunches are like the mountain range. You might be wondering if other mountain ranges have similar origins. They do. Ever push sand together with your hands? Your hands work like shifting land masses, and those peaks of sand you created are a mini version of the Rockies. The snakeskin, your shirt sleeve, the sand. The point here is that mountains get left behind when massive chunks of land smash into and slip under each other. But what about the disappearing continent that leaves them? What happened to Greater Adria itself? Just as a snake burrows underground for the winter, Adria kept sliding beneath the surface. Dr. van Hinsbergen thinks she's probably nice and cozy about 900 miles under southern Europe right now. But wait a minute. Is Greater Adria still a continent if she's underwater or under land? Is a snake still a snake when it's underground? Of course it is. In fact, I know a continent that's mostly underwater yet isn't lost at all. Ever heard of Zealandia? It's also called the New Zealand continent or Tasmantis. It looks like an archipelago, which is a string of islands. But if you peek under the water, you'll see that it's really one continuous piece of submerged land with mountaintops poking out over the surface. Those peaks are the islands. Zealandia is categorized as a microcontinent, which then begs the question: what is a continent anyway? That's a matter of some debate. In fact, we Earthlings can't even agree on how many continents, not counting the lost and micro ones there are. Generally, a continent is an enormous landmass. If you're from the US, you heard that there are 7 of them: Africa, Antarctica, Asia, Australia, also called Oceania, Europe, North America, and South America. European school kids, however, combine Europe and Asia into Eurasia, so they only learn 6 continents. South Americans also recognize 6, but they keep Europe and Asia separate and combine North and South America instead. What's even stranger is that everyone seems to agree that Australia is a continent, while Greenland isn't, and has to make do with the title of world's biggest island. Poor Greenland. This all has something to do with the tectonic plates that lie beneath the continents. But that's a discussion best left for another video. So, where did all these continents come from in the first place? Well, if you've ever looked at a globe or a map, you probably noticed that the two great landmasses surrounding the Atlantic Ocean, North and South America on one side and Europe and Africa on the other, seem like puzzle pieces that could be pushed together to form one even more gigantic mass. You might also know that there's a name for that mass – Pangea. Scientists think Pangea, a supercontinent if there ever was one, broke apart 175 million years ago, but not into those two big left and right puzzle pieces we have today. Instead, the split probably ran horizontally, leaving a connected North America, Europe, and Asia on top, a mass called Laurasia, while South America stuck it out with Africa, Antarctica, and Australia in a mass known as Gondwana. Yes, that very one that Greater Adria would break free from later on. So, if you took all of Earth's land masses, continents, microcontinents, islands, and archipelagos, and squished them together, would you get the original blob of land known as Pangea? No, like the masses connecting archipelagos. You'd also be missing all the ones lost over time. Oh yeah, there are others besides Adria. Scientists are looking for them, and they've already found some. One of those lost continents is the Rio Grande Rise. It's a stretch of underwater seamounts that's been dubbed Brazil's Atlantis. Greater Adria lay somewhere between North Africa and southern Eurasia. Hey, that's right around the Mediterranean Sea, and the Mediterranean is where Greece and Athens are. So, Greater Adria must have been Atlantis, right? Doubtful. Historians think Plato made up the story of Atlantis, but could it have really happened? You might think so if you believe the story of Greek deities punishing the civilization for starting a beef with Athens, but a more scientific theory would propose that Atlantis was simply flooded. Or perhaps it could have been one of the islands scraped off and left behind when Greater Adria dove under Europe. Disappointing as it is to say, the one thing we can't be sure of is that Adria itself wasn't Atlantis. The tectonic forces that shoved the continent under Europe did so over 100 million years ago. That's about 80 million years before any human showed up on our planet to start a conflict with Athens or anyone else. If you look at all the world's continents like broken puzzle pieces that formed a shattered Pangea, you could say that Dr. Van Hinsbergen and his team have spent the last 10 years trying to put that puzzle back together. And like actual puzzles, it's hard to do that when you're missing a bunch of pieces. I'm looking at you, Adria. But they have fancy geological equipment that tracks the magnetic record left behind in the rock's minerals. You see, every rock, stone, and mountain has a sort of imprint of the time and place it was created. It all has to do with the Earth's magnetic poles. They change every now and then in a process called geomagnetic reversal. So, in a nutshell, the specific magnetism of certain sediment and minerals works like a map and calendar. And that's how they know where Adria came from, where she ended up, and who she met along the way. By studying the magnetism of these samples, the team also found out another interesting detail. Greater Adria not only crashed into Europe, but she was also spinning on the way there. A twirling, dancing mass of land whose carefree trip northward would be cut short by an unexpected roadblock known as Europe. Hey, that would make for a great bedtime fairy tale for the kids. Now, my only remaining question is, if Greater Adria dove beneath Europe, could she rise again? It is possible. Continents keep shifting, and they remain on the move today. But they tend to go at a snail's pace. So, check back in another 100 million years, and we'll see how many continents second graders are learning about in the future. I won't be here, though. I'll probably retire. Antarctica. It was once a green land full of dinosaurs, but now it's a frozen continent bigger than that of the US that doesn't belong to anyone. It isn't hard to find. Wherever you go, just go south until you get to the big icy thing at the south pole of our planet. It lies within the Antarctic Circle, and it's the largest single mass of ice on Earth. The continent is bigger than the US and even bigger than all of Europe. And still, Antarctica was officially discovered recently. Scientists hadn't known of its existence until 1820. After the discovery, it took another 2 decades to confirm it was a whole new continent, and a few more decades after that to decide on a name. In Antarctica, anti means the opposite, so Antarctica literally means the opposite of the Arctic. Now, even before scientists discovered the land, ancient Greeks already theorized that there must be a southern continent to balance out the Arctic in the north. Also, some scientists who studied Polynesian artwork and oral history believe that Polynesians found the continent over a millennia before the Europeans did. Anyways, today we all know of this icy land at the South Pole. Because of its location, there are just 2 seasons there, summer and winter, and both last 6 months. In summer, it's a bit warmer, and the continent exists in pure daylight. And in winter, it's dark all day long. 98% of Antarctica is ice. This continent alone stores 60% of the planet's fresh water. And yet, despite all those water reserves, Antarctica is the biggest desert in the world. By definition, a desert is an area with sparse vegetation and little snow or rain. Notice that plenty of sand isn't a necessary condition here, even though the continent does have some sand and even sand dunes. It also gets a lot of wind. Antarctica is the windiest continent on Earth, and wind speeds can reach 200 miles per hour. That's even faster than hurricane winds. The little snow the land gets never melts. It just builds up over time, for centuries and millennia. So there's a thick ice layer there. This makes Antarctica full of hidden secrets. There's a whole new world underneath its ice. For example, there are a lot of mountains on the continent that are like 9,000 feet tall. It's taller than 3 Burj Khalifas stacked on top of each other, if we must, and that's currently the tallest skyscraper in the world. But we don't see all those mountains because they're all hidden under the ice sheet that's almost 16,000 feet thick. There's also a lake down there, beneath over 11,000 feet of snow. The lake is called Lake Vostok, named after Vostok Research Station, under which it's located. Originally, it was just a hypothesis. Over a century ago, a scientist suggested that the huge pressure created by tons of ice could decrease the melting point of ice in the lowest layers of the ice sheet, creating liquid water, which could form a lake. He didn't prove his ideas in his lifetime, but others continued his work and confirmed that this theory was true. There's also a canyon in Antarctica, hidden underneath huge masses of snow too. It's deeper than the Grand Canyon we have in Arizona. There is a mountain range that divides the continent into 2 parts, East Antarctica and West Antarctica. The western part of the continent is experiencing higher temperatures and is starting to melt. If West Antarctica melts and releases its stored water, it will raise the average global sea level by about 16 feet. That will be enough for some cities all over the world to completely disappear. Perhaps the first to turn into a water world will be Thailand's capital, Bangkok, which is just 5 feet above sea level. Then it will be Amsterdam in the Netherlands, followed by Ho Chi Minh City in Vietnam, Cardiff in the UK, and New Orleans in the US. People do a lot of work in Antarctica now, residing there for many months at a time to study this mystery of a continent. Over the years, even a few children were born there. But it's not a country, and the land doesn't belong to anyone. It's governed by the Antarctic Treaty System, an agreement of peaceful research and collaboration that suspends all territorial claims. It was first signed by 12 nations, and now there are 59 supporters, half of whom have decision-making powers. The continent is occupied all year round by researchers from all over the world. There are about 5,000 people living there in summer and about 1,000 in winter. Yet no one is a permanent resident there. People come and go, and the scientists take turns spending time there. The average yearly temperature there is negative 30 degrees. But there was a time when Antarctica was about as warm as Melbourne, Australia is today. It was about 40 to 50 million years ago. I wasn't around then. But the continent had green forests and dinosaurs roaming its land, chilling in the sun in a 63-degree Fahrenheit environment. That was before penguins. In our age, it's so cold that you won't even find any trees or bushes in Antarctica, just the snow. The only plants that can thrive in such extreme temperatures are lichens, moss, and algae. People can't stand such freezing conditions for lengthy periods of time either, so the continent has never had any indigenous population. Well, that is, if we don't count penguins, seals, whales, and a few other types of birds that live there now. Antarctica's fauna is the scariest and least diverse on the planet because only a few organisms can withstand its harsh conditions and because non-natives aren't allowed to be brought there. So, if you decide to travel to Antarctica with your cat, well, you can't. Hey, I don't make the rules. But those few species that live on the South Pole totally own the place. There are no more than 5,000 people there and around 20 million penguins. They are a kind of settlers, though. Penguins' first ancestors lived in Australia and New Zealand. There are still a few penguin species there, including the smallest penguin on Earth that is just 1 foot tall. Still, most of the penguins migrated to Antarctica at some point, possibly because they were attracted by the greater food supply there. It's not the cold that made them like the land. It turns out, most penguins leave the continent when the summer ends. The only ones that stay there are male emperor penguins, and they do it to warm and protect eggs left by their mates. But where do all the other penguins go? At first it was a big mystery even to scientists, but then they attached some tiny location devices to the legs of a few of these animals and figured it out. Penguins go to live in the southern oceans while it's too cold in Antarctica. None of them go ashore for half a year until they get back to the continent. When they come back, it's when those eggs, left for male penguins to nurture, start hatching, and so penguin families can be together when it happens. Penguins eat different fish, and the ocean is full of those despite its cold temperature. In some areas, water can reach below freezing temperatures because it's salty. But fish don't freeze there because they have antifreeze proteins in their bodies. Then there are also about 1 million seals in Antarctica. They like fish too, and they can hold their breath underwater for 2 hours. They see way better underwater than in the bright light of the day, and they also use their whiskers to locate food. Their breathing holes in the ice can freeze while seals are away, and they must use their teeth to make a new one. Seals can even sleep underwater and then resurface occasionally to get some air without waking up. I can appreciate that. You'd be surprised to find out the life-changing discoveries a person can make just by browsing Google Maps. Like this guy, who found a suspicious crater and might have made a major scientific discovery. In 2024, Canadian Joël Lupoint was planning a casual camping trip in his homeland. He opened Google Earth and zoomed in Quebec's Côte Nord region. That's when he saw it, this unusual rounded structure. The measurement was impressive, 9.3 miles from one point to another, and there seemed to be a lake next to it. He was quick to print the screen and sent the image to a French geophysicist to see if he knew anything about it. Most times these images turn out to be nothing, or simply Google Earth watermarks. But he was surprised when he opened his email and saw the scientist's reply. The geophysicist said that, judging by the looks of the topography, Lapointe could have discovered a meteor impact area. Now, impact areas are really hard to identify. Since they've been around for millions of years, most of their shapes have been heavily changed by erosion. Scientists call these areas impact structures. They're usually circular or crater-like and are made up of deformed bedrock. It happens when a meteor falls into the surface of the Earth. Here's the thing. Since the crater has huge walls around it, these areas are usually mistaken for mountain ranges. That's what left the Canadian explorer confused. But the French geophysicist that analyzed the case gave him hope. That weird formation in Quebec had been classified as a type of volcanic formation. After Lapointe brought this subject back to the agenda, scientists had to dig a little deeper to find the truth. Until this recent discovery, scientists thought the area looked like that due to some volcanic formation. This is actually normal, since other things such as volcanism and sinkholes can be mistaken for impact craters. To verify, they asked for some samples of the site. This is a more reliable way to fact-check whether a meteor landed there or not. When the meteor hits the Earth, it brings different types of minerals from outer space. That's the wonderful thing about impact craters. They reveal a link between Earth and the outside universe. By now, scientists have cataloged most of the minerals that are native to our planet. When they're searching for an impact structure, They usually look for things such as Teenite and Chemisite, which can only be found in meteors. The biggest known impact crater in the world is the Vredefort crater, located in South Africa. This big thing was formed some 4 billion years ago. The asteroid that made it is estimated to have been one of the largest ever to strike planet Earth. When the researchers got the results of the site back in Canada, they did confirm that it contained zircon, a mineral that tends to show areas of impact. There's no way to guarantee that LaPointe really found an impact crater, but scientists are organizing a research mission over to the area just to make sure. If it turns out that it really is an impact crater, that's pretty huge news, since the last discovery was made in 2013. Another one of these mesmerizing discoveries came from a 15-year-old boy. William Goddery was also a Canadian, and for some reason loved looking for long-lost Mayan cities. Different from the previous story, William had an intention and a research methodology. He had studied many books on Mayan civilizations. He believed that Mayans built their cities in relation to the stars in the sky. So he opened a book and mapped all the cities that have already been unearthed. And that's when he noticed something important. There is an area in the Yucatan Peninsula in Mexico where archaeologists have unearthed 2 Mayan cities. But on the constellation map, there are 3 stars. He thought to himself, could this mean there is a lost city waiting to be discovered nearby? William Goddery is known to be a science genius and has even won an award for this constellation theory. When he noticed that a 3rd city was missing from the 23rd constellation he was examining, he began to search Google Earth for satellite pictures that could help him solve this mystery. Advances in satellite tech have shed new light on long-lost Mayan cities such as Tikal. Located in the heart of the Guatemalan jungle, Tikal is believed to have been the capital of the ancient Mayan Empire. He had hopes, so he reached out to a friend inside the Canadian Space Agency to verify what he had found. Since he had already won awards for his research, he had friends in high places, and that's when things got interesting. According to the images, there was a large square area on the border of Mexico and Belize that looked like the remains of a city. William took the images to a remote sensing expert. They studied the images thoroughly and concluded that the area could be housing 30 buildings and even a large pyramid. William named the new city discovered as Mouth of Fire. However, his theory was very much contested inside the archaeological community, and many Mayan experts worked to debunk William's findings. Experts say that constellation theories are too unscientific. Renowned anthropologists and astronomers said William's methodology was an act of creative imagination. Still, a 15-year-old teen almost found a long-lost Mayan city, which is pretty exciting if you ask me. What about these tiny dots that appeared on images of Google Earth? These strange spotted circles were found in the middle of the Algerian desert. A YouTuber browsing on Google Earth found these circles and discovered that people had been debating over their origin for years. He thought they were a glitch from satellite images. There are dozens of them, stretching for miles and miles in a straight line. They're far away from any town, road, or human activity, making it hard to understand if it was man-made or just a natural phenomenon. To settle this mystery, he interviewed the people who took Google Earth's pictures. He found out they were 100% true. The circles were there in real life. They appear in multiple pictures from multiple years. Now, at first, he guessed they were the result of oil activity. Algeria is a rich area for natural resources, so this made sense. To find out if the area is worth extracting, companies usually undertake seismic surveys. They're a way of analyzing the Earth's surface by sending shock waves into the ground. Depending on how these waves bounce back, you'll know what is located underground. There was another possibility. The Sahara is a very dry area of the planet. The average high temperatures in summer are over 104 degrees Fahrenheit. To survive there, people need to find ways of accessing water. So his second guess was that the circles were a kind of ruin or leftover from ancient water wells. But when he talked to an expert, he found out they weren't ancient water wells. You can see some of these traditional constructions in other cities on Google Earth. and they look really different from the mysterious circles. He decided to travel over to Algeria to find out the truth. He drove 99 miles into the heart of the desert, and when he gets there, he sees it, a huge crater dug on the sand surrounded by 12 smaller holes. It kind of looked like the ancestor of a modern clock. There, he found something he couldn't spot on Google Earth: thin metal wires. When the curious YouTuber and his teams started to dig in the sand, they found old dynamite and some sardine cans. Apparently, they were hiding the truth. The Sahara Circles, as they were famously called, were not the historical leftovers of seismic surveying. Back at the time when these circles were made, this technology didn't even exist, but they were sure related to oil exploration. The dynamite holes were an ancient method of oil searching, and the sardine cans? Well, they were left by the workers who were exploring the region. Another Google Earth mystery solved.
The theory of parallel worlds has been discussed in the scientific community for a very long time. Unfortunately, we're not developed enough yet to prove or disprove it. But it's still an interesting theory, and that's why we have a lot of unusual urban legends about the guests from a parallel reality, according to many. Let's check out a few of them. A man from a non-existent country. This story took place in 1851 in a small German village, Frankfurt an der Oder. A lost man came out to the local villagers asking for help. The man introduced himself as Jopar Voren. He spoke very poor German and had a very strong accent. The man himself claimed that he speaks Laxar and Abram, languages that don't actually exist on our Earth. He claimed to be from Laxaria, a country on the mainland called Sacria, separated from Europe by a huge ocean. However, none of these places existed on the Earth's map. People sent Jopar to the local authorities. He talked to a psychiatrist, but the doctor concluded that the man was totally sane. An investigation by the local police also revealed nothing suspicious about him. Jopar Voren claimed that the purpose of his visit to Europe was to find his long-lost brother. He survived a shipwreck and found himself near the village. They showed him a map of the world and a globe and asked him to indicate the place where he crashed, but he didn't recognize anything familiar. He seemed to have extensive knowledge about his homeworld. Jopar named 5 main continents on it: Sacria, Aflar, Astar, Auslar, and Uplar. His story was considered plausible. Scientists from Frankfurt decided to send the man to Berlin for further research. However, during the trip, he had something like a seizure. The man suddenly jumped out of the carriage and disappeared into the surrounding forest. Despite a long and thorough search, no traces of Jopar were found. He seemed to have disappeared as mysteriously as he had appeared. Inspector Leboeuf, who was assigned to escort him to Berlin, thought this man could be a being from another world, and that he had returned from where he had come from. Lady on Highway 167. This incident happened on October 20th, 1969. It was first reported in 1988 in the magazine Strange. The article tells about 2 men, LC and his business partner, Charlie. The names are fictitious. One afternoon, LC and Charlie were driving along Highway 167 in southwest Louisiana. Discussing work, they drove toward the oil center of Lafayette. The highway was empty at first, but then the men noticed a very old and very slow car ahead. The men started discussing this mysterious car. Such cars hadn't been produced for several decades, but this one looked quite new. The men thought it was thanks to the owner's care and admired it. They slowed down to get a better look at the car. LC noticed a bright orange sign on it that said 1940. They saw a driver. It was a young woman in old-fashioned clothes, a hat with a long feather and a fur coat, even though it was warm outside. There was a child next to her, also dressed in a warm coat and a hat. LC and Charlie wanted to talk to her, but then they noticed the expression on her face. The woman was looking around in panic, almost on the verge of crying. LC called out to her and asked if she needed help. She nodded, and he gestured for her to park on the side of the road. But when the men also parked, they suddenly noticed that the woman's car had disappeared. They looked around the highway in shock. She couldn't have gone somewhere far so fast, but the car was nowhere to be found. After some time, another man drove up to LC and Charlie. He saw everything that happened and claimed that the car had simply disappeared. The men talked about the incident for several hours. When they reached the city, they contacted the police. However, the police couldn't help them in any way. Apart from their words, there was no confirmation of the existence of the car. The case was discussed for a while in local newspapers, and then was forgotten. The Gadianton Canyon Incident. This incident occurred in May of 1972 in southeastern Utah near the Modena Railroad crossing on the edge of the Escalante Desert. Jenna North was driving her father's 1971 Chevrolet Nova. Her friend, Carol Abbott, was in the passenger seat. In the back seat, there were two other girls, Lisa Rockford and Bethany Gordon. It was after 10 p.m. when the girls crossed the Utah-Nevada state line. They wanted to get back to campus before their housekeeper, Mrs. Mortensen, locked the dorm doors. This stretch of Highway 56 in Utah is pretty deserted. There's nothing there but sand and a few plants. The girls were very happy when they finally noticed the Union Pacific Railroad crossing in Modena. But right behind the railing, Jenna noticed two highways. One went into the desert, and the other to Gadianton Canyon. The girls decided to take the road to the canyon. They thought it would be a shortcut to campus. The other girls were chatting with each other when Jenna noticed that they were no longer driving on asphalt, but on white cement. "Watch out!" suddenly shouted one of the girls. The road ended abruptly at a high rock wall. It was a dead end. They had to go back the same way they came here. And while Jenna's friends were complaining that now they would have to sleep in the car, Jenna saw that the landscape had changed dramatically. They weren't in the desert anymore. Instead, the canyon turned into an open area with wheat fields, pine thickets, and a small lake ahead. A full moon was shining in the sky, which was strange because it shouldn't have been there that night. The girls had no idea where they were, so they just drove to the light ahead. It was some building that they thought was a diner or restaurant. The girls saw a bright neon sign, but none of them could read what was written on it. These symbols were unlike any language they knew. Suddenly, several people came out of the building. They seemed shocked and frightened by Jenna's Chevrolet. They waved their hands and shouted something, but the girls didn't understand them. Lisa decided to ask the men for directions. She stuck her head out of the window and immediately let out a terrifying scream. "Get out of here!" she shouted to Jenna. The Chevrolet sped away from the building. Bright headlights illuminated their car from behind. They were being chased by a few vehicles. These vehicles were egg-shaped, had 3 wheels, and made a buzzing sound. The road ahead led back to the canyon. Jenna didn't have time to slow down and crashed right into it. The vehicles had disappeared, together with an unfamiliar landscape. The girls were back in the desert again. Fortunately, none of them were hurt, physically. But Lisa was in a state of shock. She was saying again and again, "They weren't human!" The girls had to help her walk. An hour later, they were able to stop a Utah Highway Patrol car. They told the police their story. The details of the report compiled by the police officer were complicated and confusing. During the investigation, the police couldn't figure out from the tire tracks exactly where the car went astray. The tracks ended very abruptly, as if the Chevrolet had suddenly disappeared. The police couldn't explain how the car could have driven 2 miles without leaving any traces, especially on such solid ground. There are still disputes about this story, but in the end, all versions and explanations of what happened are just guesses. Perhaps we'll never find out the truth. These were the urban legends about interdimensional traveling. Of course, there's no proof that any of these stories are real. Often the truth turns out to be very mundane. For example, the famous man from Taured, who people also called a guest from another reality, turned out to be a simple fraudster named John Allen Kuchar.